Just remember that I think yesterday an announcement with the study guide for the exam that we have on Monday, and also two practice exams. I'll send the solutions for the practice exams in the evening today. But yeah, just like it's kind of like it will be basically the same format as last time. So just take a look at the practice exams and the problems we have done during class. The problems are recommended for the quizzes, and I think you should be fine. So today, yeah, what we're going to do today is not going to be on the exam. That's why I'm starting a new PDF. Um, Let me just put that. So this would be lecture 14. Are there any questions maybe before I start with this? So it's actually one of the more interesting chapters on the book, the stuff that we're about to talk about, because it's like material where you will use like the derivative of a function to find like information about the function. So it's kind of like the more applied part of the course where we're actually using now that we are kind of acquainted with finding derivatives, we're going to use them to extract other information about how the function behaves. Okay, so the first application that's very common when you're studying the first derivative of a function is to determine the maxima and minima of a function. So let's call this first application. Finding relative maxima, and relative minimum. Okay. So let me try to explain what I mean by that. So if you remember a good idea for thinking about a function in terms of its graph, is the function, the graph of a function, well, it gives you like a curve on the xy plane, but you should think of that curve from some sort of like roller coaster or something like that. Okay. And if you think about it in that way, well, usually in like in this analogy or in this metaphor, you think of it like as a ride that always moves from left to right. So you always move in the direction where x increases. So you move kind of like this. So what would you see on this ride? Well, first you're increasing your height, right? Then you kind of reach like a peak, and then you start coming down. then you reach this the bottom of the roller coaster, right? And then you start increasing again your height. You reach another peak, and then you start coming down again, right? Um, and well, whatever happens next depends on how this graph continues, right? Here I'm just showing you like some portion of the graph. But if you see in what's happening here, is that you're kind of like it's not that, well, I guess, so, but it's, you kind of are reaching certain points where you reach like some sort of maximum, and then you reach certain, you're going through certain points where you reach some sort of minimum in terms of the height, and that kind of like, oops, keeps occurring. So is that making sense? Up to this point, I'm using different colors to distinguish between them. And notice that if I say that this is like a maximum, right? I'm not claiming that I should put like the other one. I should also call the other one maximum. When I say that this is kind of like a maximum for this function or this roller coaster, I'm not saying that this is the highest point, right? In fact, if you look at on the entire picture, there is a point that's higher, right? So that's why this is called like a relative maximum, because it's kind of saying like it is just the highest point relative to some fragment of the curve, so to some portion of the curve. Is that making sense? And by the same logic, here, when I say that this is a minimum, like I just don't know what's happening with the rest of the curve, so I cannot guarantee that this is actually like the lowest point. I just know that it's a lowest point relative to some portion of the curve. In fact, to a big portion of the curve, that's like the minimum. But it's not like a claim that it's supposed that it's like the guarantee that it would be the lowest point that you would find. So is that making sense? So when when we were finding the maxima and the minima of the function, we're at least at this point we're just finding them as relative maxima or relative minima, because we're not looking for necessarily the highest point on the graph. Okay, so the function f of x has a relative maximum. Let me use that this color at a point A if f of A is the highest value the function takes on an interval containing A. Or the largest, let's call it. So what I'm trying to say is that this is a relative max because there's some interval. I mean, the interval can be actually bigger than the ones that I'm drawing, but there is at least some interval where this is the largest value of the function, the biggest value of the function. Okay, and similarly, this will be a minimum, a relative minimum, because there is some interval, which again can be pretty big, in fact, where the smallest value of the function is this one. Okay. So I mean, I'm trying to give you like the definition, but it's actually easier just to understand it from the pictures. Okay. So is that making sense? Any questions about this? Okay, so now the next question. Okay, so based on this roller coaster picture, like the functions sometimes have have maxima and minima, right? So the next step is kind of to identify them, right? So how to identify these. So the quest is how to find the relative maxima and relative minima of a function. Okay, but so what do you think? Again, like if you follow the roller coaster analogy, right? What's happening here? This is a maximum, right? And if you think about it in terms of the roller coaster, what happens as you approach this maximum? First, your height is increasing, and then your height is decreasing, right? And similarly, for this maximum, when you are approaching it, you are first increasing, and then your height is decreasing. Is that making sense? So I don't know if you remember in terms of the first derivative, when is the function increasing? What's the sign of the first derivative when you are increasing? The first derivative was positive, and when you're decreasing, the first derivative becomes negative, right? So it kind of looks as if the first derivative at a maximum is switching from positive to negative. Is that making sense? Positive to negative. Let's try to put this like this. Positive, negative. So let's put a plus sign here, a minus sign here. Positive, negative, right? And what is happening at a minimum? At a minimum, you kind of are decreasing your height first. You reach the minimum, and then you start increasing it again. So what's happening at a minimum? It is actually it's going first decreasing and then increasing. Is that making sense? Well, and if you understand that, then you more or less know everything that is needed to do this. So how can the derivative, like how can the first derivative change from positive to negative? Well, if you think about it, like for number, if you have a bunch of numbers that are first positive and then become negative, you would expect that it had to become zero at some point, right? Um, and here it's similar. If you're going from positive to negative, you would expect it to be zero at some point, which should be the maximum. And if it's going from negative to positive, I mean, also going from negative to positive shouldn't happen unless you became zero at a point. So, what these two things have in common, max or mean, is that their first derivative should be zero at the max or at the mean. Is that making sense? So that kind of is important. So um it takes you give a special name to when that happens. So let me write that down. A point A is it's called a critical point. It's a critical point of the function f of x. If the first derivative becomes zero at this point. So what does that mean? It means that f prime of A equals zero. Or also, so that's, or the first derivative is undefined at this point. So that's something I'm not showing you on this graph, but another possibility for being a critical point is that the first derivative is undefined. Okay. Is that making sense? So one very common thing in this calculus, like one of the most important things about a function is finding the critical points of that function, because those are the candidates for max or min. So let me do some examples about this, but let me check first if there are like any questions up to now. Is that okay? So let's do some examples. So to find the critical points of a function, what you have to do is find the first derivative of that function. So what is the first derivative of this function? Is 3x squared minus 3. Is that okay? And then you need to, by the way, usually in these problems about finding critical points, like the functions themselves are not too hard. So usually finding their first derivative is relatively straightforward. Now when once you have the first derivative, you need to check when the first derivative becomes 0. So for which values of x does this equal 0? What do you think could be that? Good. X equals 1 or -1. Well, how do I know that? Oh, you have to solve 3x squared minus 3 equals 0. To solve that, you can divide by 3 on both sides, so you get x squared minus 1 equals 0. And then this, if you use the difference of square formula, you get x minus 1 times x plus 1 equals 0. So that means that, so x equals 1 or x equals -1. Is that making sense?
On like the quiz, would we be allowed to write would we be allowed to write x equals plus or minus 1? Or did you want us
Uh,
to separate it?
well, at least for today's quiz, this is not on the quiz, but in general, the way I would for these types of problems, I would either give you like a box for you to enter the value for it. Like say if there were like two options here, like I would give you two boxes for you to put the corresponding values for x. Or there's also on the quiz format an option to like just like a text where you would just type it. So you could either type it as x equals 1 or x equals -1 or x equals plus or minus 1. That's fine. But so yeah, it's not like a as long as you found both of them, it's not such a big thing on how you enter it. So, but yeah, depending on what option I choose for you to enter the answer, like either you would see two boxes or it's just like a single line of text where you just like write down the answers, if that makes sense. Any other questions? Okay, let's do a different one. Let's see what you think about this one. Let me check. Okay, let's do this one. So let me give you a chance for you to do it on first, and then we'll discuss it. So here's example 2. So try to find the critical points of this function. Let me give you 3 minutes to think about it, and then we'll do it together. Just we'll bring more coffee. So what's the value? What's the critical point? I think there was only one. What value for x did you find? Yeah, it should be -1. Good. How can we do that? Again, you find the first derivative. How do you find the first derivative of this function? You have to use the product rule. So it's x prime e to the x plus x e to the x prime, right? That's the product rule. Then the derivative of x is just 1, remember? So you get 1 e to the x plus x, and then the derivative of e to the x is itself, right? So you get e to the x of 1 plus x. And that, for the critical points, you need to set that equal to 0. Right, so for the critical points, is when e to the x times 1 plus x equals 0, right? So when can this happen? When can the product of two numbers be 0? When e to the x equals 0 or 1 plus x equals 0. But if you remember, like, this is where you do need to remember a little bit about some facts of the exponential function. The exponential function is never 0, right? It's actually always positive. So this never happens. And this happens when what? And this happens when x equals -1. Okay, so the critical point occurs at -1. Is that making sense? Any questions about this up to this point? So again, like one of the reasons why usually like finding the first derivatives of these functions is not too bad is because you then have to set this equal to 0 to find the critical points, and usually it has to be like an equation where it's relatively straightforward to see when it becomes 0. So um, for these problems about finding critical points, it's more like a combination of some basic derivative rules with some algebra, because you do require some algebra skills to, set this equal to 0 and solve for it, solve for x. Okay, but this is enough. Okay, so now that we have done a little bit about this, how to find critical points, the idea, for example, is that here, this is a candidate for being a max or a min. This value for x is a candidate for being a max or a min. Or in the previous example, these two values were candidates for being max or mins. So now, again, the concept of critical points is something that includes being max or min. So we kind of have to distinguish between those two possibilities. And so for that, we have to go back to what I was telling you about the first derivative. You have to analyze what happens with the first derivative around near those critical points, and that's called the first derivative test. Okay, so this is like one of the important tests or things about calculus. If f of x has a critical point at a, and the first derivative changes, and the first derivative f prime of x changes from positive to negative, then a yields or f of x has a relative maximum at a. So this is one way to remember it. In terms like you kind of draw some arrows. So I'm saying that the first derivative changes from positive to negative near a. Near so again, it is like this roller coaster analogy. When the first derivative is positive, that means that the function is increasing. So that's why I'm drawing like an arrow. That means that you're going uphill. And when the first derivative is negative, that means that the function is decreasing. So that's why you're going downhill. So if you kind of just join these two arrows together, it looks like there's some sort of max here. So this is where the max occurs, or the relative max. I think which color that had I used for these? Well, the other one is that okay, maybe I should stop here before writing the next one. Is this making sense so far, so good? And then the other one is basically the same for the relative mean. It's just you go from negative to positive, right? So from negative to positive near a, then f of x has a relative minimum at a. Is that making sense? Any questions about this so far? Okay, and this is enough to find max and min in some of the problems we did earlier. So let's try to do that. Well, here's an example. Of f of x equals x cubed minus 3x. So we already, so remember here, like the first derivative was 3x squared minus 3, which is the same as 3x squared minus 1. Which is the same as 3x minus 1, x plus 1, right? So we had seen that the critical points were at x equals 1 and x equals -1, right? So here's what you're supposed to do. What you can do to analyze this is you can draw the x-axis, right? And on the x-axis, you identify the critical points. So let's put here -1 and 1. And then again, I should probably write the first derivative is 3x minus 1, x plus 1. And then what you're supposed to do is kind of say what happens with the first derivative, right? So for example, if you choose a point that's to the right of 1, right? If you choose a point here, what can you say about the sign of the first derivative? What would you say? Is it positive or negative? Here's a trick to yes, and here's a trick to find it. Actually, it does work. So if you're not sure of what the first derivative is positive or negative, you can take a test value. So let's take an easy number, which is 2. And so what's the first derivative of 2? It would be 3 times 2 minus 1 times 2 plus 1. And what does that give you? It gives you 9, right? Which is positive. And there was nothing special about 2. If you had chosen like any number, any number bigger than 1, and you had plugged it in this formula, you would have found a positive value. So in fact, like to check it, it suffices to just choose 1, and if the sign that you get from this choice is the same sign everywhere else. Is that making sense? So it is positive. So since it's positive, you can draw the arrow that's increasing. Is that okay? Are there any questions about this? far so good. This is kind of the most important part here. So let me know if this is making sense. Now let's look at this interval at the points between -1 and 1. What do you think is the sign? What do you think is the sign of the first derivative if you choose a point between -1 and 1? And again, you can, it has to be either positive or negative. So what should it be in this case? Okay, so how would you know that? You could make a choice. You can do the same thing that I told you for this one. So choose your favorite point on this interval. What's a point on this interval you may want to choose? Yeah, x equals 0 is the easiest one. So if you choose x equals 0, what's the first derivative at 0? It gives you 3 times -1 times 1, and that gives you -3. So it is negative, right? So you can draw an arrow. So the first derivative is negative, so you can draw a decreasing arrow. Is that making sense? Questions about this, anyone? And you can do the same for this remaining piece of the number line of the real axis of the x-axis. So choose your favorite point on this interval. Well, you can do -2, for example. And what is f prime of negative? Oops, let me change the colors. What is f prime of -2? It would be 3 times -2 minus 1 times -2 plus 1. This gives you -9. This should give you 9. So this is positive. So since this is positive, since the first derivative is positive, you should draw an increasing arrow. Is that making sense? And so what's happening here, again, if you think about it in terms of the roller coaster, if you think about it here, you're first increasing and then decreasing, right? So what should -1 yield? Should it yield a max or a min? You kind of put the two arrows together, right? So it should just be a max. And what's happening here, again, if you follow the roller coaster, you are going downhill and then uphill, and that's what you should feel is that should be a min, right? Is that making sense? Are there any questions about this? So we'll learn about how to sketch this functions in a bit, but at least let's just cheat a little bit and I'll show you how this looks like. So if you take f of x to be x cubed minus 3x, you get this function, right? And one critical point was -1, comma, like f of -1. That's where you see, that's what you see here, a. And the other point was 1, comma, f of 1, right? So the other point on the roller coaster is this one. And so you see, it went from increasing to decreasing, so that's why this was a relative max. And then it went from decreasing to increasing, and that's why this one was a relative mean. Okay, and the point is that already knowing the signs of the first derivative, you can kind of have anticipated that the graph had to do like kind of look similar to this. Okay, so again, we'll spend more time talking about curve sketching, like probably next week at some point. But one of the problems that we'll solve later will be like, I give you this formula for the function, find the graph, or like find a sketch of the graph, and you should be able to come up with something that looks relatively similar to this. Is that making sense? So, just as another, let you do the other example. So remember, example number 2, I had given you x times e to the x. So try to find, okay, so let me give you, yeah, let's take a break, coffee break combined with a chance for you to work this out. So remember a couple of minutes ago, we had found the critical point for this function. So try to identify that one as a max or a min, and we'll discuss it together. And also let's do a small break. So let's meet at 2 p.m. so that you have time to do all of this, and then we'll talk about this, and I'll tell you a few more things before the quiz. Okay, so what did you find? Was this point like a relative max or a relative mean? The first derivative, what was the first derivative? Was e to the x times 1 plus x. Right, so there was a critical point at x equals -1, and that was the only critical point, right? And so once you have that, you have to analyze the sign of the first derivative near away from this point. So for example, here, if you take a point here, which point could I take? I could take 0, right? So what is f prime of 0? That's e to the 0 times 1, right? What is e to the 0? That's just 1, right? So the first derivative is positive here. That making sense? Let me use a different color. And then you can take a point to the left of -1. Like for example, you could take a -2, and so if you do f prime of -2, you get e to the -2 times what? 1 plus -2 equal what? Something like this, minus 1 over e squared. And well, we don't know what 1 over e squared is, but again, the exponential is always positive. So this has to be like, because there's like a minus in front of it, it has to be a negative value. So this has to be negative. Okay, so we're going here from negative to positive, right? Negative to positive, so that should be a relative mean. Is that making sense? Let me show you again this in GeoGebra, how it looks like. So the critical point was -1, f of -1. So it's somewhere in there. And this is a bit more subtle, that this is a mean. You kind of have to zoom in a lot for it to look like a mean. And it's like a very subtle, like, you know, it is not as clear as sorry? I don't know. I couldn't tell what you were asking. You can type it on the chat. I don't know if the audio was that great. But yeah, this is like a very subtle mean. So you can barely notice it. That's why it's also useful to have something besides the sketch to be absolutely sure that it was a mean, right? So we are sure that this is a mean because we analyze the sign of the first derivative. Because like, if you had to tell by the graph, you can kind of tell, but it is not so easy. You see, so that's why doing this algebraically and not just like visually is also useful. Is that making sense? Okay, and just let me, before moving to the quiz, just I don't want to start like it's something brand new, so let me just mention some couple quick things. Another remark, if you look, for example, at the function absolute value of x, well, if you remember the graph, um, if you look at this graph, there's a minimum at 0, right? So that means that 0 is should be a critical point, and this is more or less why we allowed. If you remember the definition of critical point, the definition of critical point is that the first derivative becomes 0 or it does not exist. So the fact that we are allowing it not to exist is to kind of include cases like absolute value. So if there is a corner, the derivative does not exist, but still it can be a minimum or a maximum, for example. So there's a minimum, a relative minimum. X equals 0, but f prime of 0 and f prime of 0 does not exist. So this is an example of a critical point where the first derivative is undefined. Is that making sense? Is that okay? So corners can be max or min, but at corners there's no derivative. So that's why you kind of have to include them in the definition of a critical point. And then the other remark that I wanted to mention before moving to the quiz is if you check the first derivative test, right? In the first derivative test, we did plus minus or minus plus, right? So what other combinations do you think of plus or minuses? I mean, I didn't include here. So I'm doing here plus minus, minus plus, what else is left? Plus plus or minus minus, right? So what happens in those cases? In those cases, there's no max nor min, right? So for example, here's another example. What about f of x equals x cubed, right? What is f prime of x? Is 3x squared, right? So there's so x equals 0 is a critical point, right? But what happens with the first derivative in this case? So you have 0 here, right? You have the critical point 0. But what is the sign of the first derivative? The sign of the first derivative is 3x squared. Since it's x squared, right? It's always positive. It doesn't matter the value of x. Is that making sense? So this is like a case where the first derivative is always positive, so it's, the function is always increasing, right? So let me show you that. So if you look at something like, this is a graph of x cubed. So I'm saying we have the point 0, f of 0, that's a critical point. But if you look at this point, right, this is not a max nor a min, right? Because the function is always increasing. There is something interesting that's happening here. Basically, there will be a thing called the concavity that changes at this point, but for now, you can ignore that. The only thing that I'm trying to say is that this is an example of a critical point that's neither a max nor a min, okay? So that can happen, and when that happens, that's called an inflection point. Let's just, let me introduce, so neither max nor min. Max nor min. So the last definition for today is that a critical point is called an inflection point if it is neither a relative max nor a local min. So this example is an inflection point. Is that making sense? So inflection points in terms of these diagrams with the signs happen when, for example, if you saw plus plus or minus minus, that's an indication that there's an inflection point. Is that okay? Are there any questions about this? Just give me 1 minute, sorry. Okay, so for now, yeah, I think this is a good place to end because like the next topic would be entirely new and I don't want to start it right now since we have the quiz. So before moving to the quiz, just as a reminder, so the exam is on Monday. It's exactly the same format as the first exam. So when you log in on Canvas, you'll see a first part that's available from 1 to 2 p.m. It will be 3 problems. You do the upload for those problems, and then part 2 will become available from between 2 and 3 p.m. and then you have 15 minutes to upload them as well. As I said, like I'll send you the solutions for the practice exams today in the evening. And I think if you do the practice exams and then you do go again over the examples we have done in class, and if you do the recommended problems for the quiz, then I think the exam should be relatively straight. It should be very similar to all of that. So I don't know if there, well, maybe are there any questions about the exam before moving to the quiz? Um, I'll still on Monday, of course, like if there's like an emergency, I'll be checking the email when you are taking the exam, so you can let me know. So I will be around in that sense. But you don't have to log in through to the Zoom meeting. Um, you can just take the exam directly. It will be 3 and 3. So let me just make available the quiz. For those of you who want to start taking it right now. So let's see. Okay, yeah, now you should be able to take the quiz. So you can log off, start taking it. And if you want to ask me something else, you can ask me right now. That's fine. Hi, everyone. We can YouTube. Yeah.
Can you hear me now, Professor?
I can.
Okay, my mic wasn't working. Just a quick question on like related rates
Mm-hmm.
for the exam.
Yes.
I was looking back at the example that we did at the end of class yesterday.
Mm-hmm.
It was the one with the ladder and the
Uh,
tree.
right.
So when you're talking about like if you're given the rate that X is changing or that the base of the ladder is moving away from the tree, and
Mm-hmm.
it's telling you to find that the base of how high the rate of change when the height is at a certain number.
Uh-huh.
Uh for finding like when would you know to use trig functions? Because like the example before, the one with the weather balloon, right?
Uh-huh.
We use a trig function. So like even if we're not given an angle, would it still be okay to use a trig function if we have the values, then find the angle?
I mean, so you can always use like, how should I put it? Like, right, you could have done it with trig functions for sure. Uh, It's just that in this particular problem, I had not given any information about the angle, right? So that's why it was not like necessarily like the best idea to do it with the angle. You know what I mean? But
Mhm.
if you could have found like if you want, I could go back to am I still recording this? Yeah. So I can show it to everyone for those who are already taking the quiz. Um, He said I had a problem. I mean, there was one more small thing. Now the quiz should be available. Just let me check something quick. Um,
Mhm.
yeah. It's like I did a silly thing on the quiz, but now it's fixed. So I think everyone should be able to see it now. Uh, yeah. So let's see. I don't know what happened. Wait, give me a second. Where should I? Oop, yeah, no. Now it's fine. I'm just trying to check. Like I don't. Oops. Let's see. Yeah. No, it's fine. So okay. So for example, in this this is what's the other PDF? Right. So you wanted to use something with angles, right?
Mm-hmm.
So what I had done was Pythagoras theorem, right? But
Yeah.
you could also like yeah, if you had called like I'm about to erase it. But if you had called like theta this angle, right?
Yeah.
Then you could have said yeah, like maybe the I don't know the tangent of theta is y over x, right?
Mm-hmm.
Uh, and then you multiply by x on both sides, so x tangent of theta equals y, right?
Mm-hmm.
And then you take the derivative of both sides with respect to t, and that would allow you to relate dx dt to dy dt, right? It's just that you would also need the theta dt, and that's let's see, that's what's not so easy to find in this problem, if you know what I mean, because it's not you kind of almost to find the theta dt, you would need to know the y dt. So
Yeah. It's like
it's
so the
it's not the right.
so the way I was thinking of it was that since we knew that x was like the height we were looking at, the base was 7, then I was
Mhm.
thinking you could use cosine to find
Oh,
the angle.
well, so the thing, okay, yeah, you can. No, you could totally find the angle. It's just that when you take the derivative with respect to t, the angle it does depend on time. You see,
Mm-hmm.
so it's not. You would need the theta dt. That's what I'm trying to say,
Oh,
and
because
that's what.
because the rate of the angle is changing at a certain time as well.
Right, and
Got you.
that's
Okay.
not, and that's what prevents you from using the trick stuff here.
I see.
Is that making
So
sense?
like in the example before this with the weather balloon, so that's what we did there, where d theta dt was the rate that the angle was changing for the
Right.
time.
Yes.
I see. I see. Okay. So
Yeah.
then basically like if we're given the value of the angle, or if we're looking, I guess the only time we would use trig functions is if we're looking for something related to the angle, if it's the value or if it's the rate of change.
More or less, basically. Yeah.
Okay. So then
Yeah.
like I mean I guess for the exam it could be either or, right? Like it could be
Right. Yeah. It's just like, I mean, kind of like, that's why once you kind of like identify all the variables in the problem, like,
Mhm.
it's like you just kind of have to look at what's the information about the variables that you're given, right? Once you have that information, then like you have to find an equation that relates those variables and no additional variables.
Got you.
Otherwise,
Okay.
it's not too useful. Is that making sense?
Yeah. Now I mean, I was just wondering because like that, like this is like the
No,
last
no,
topic of the exam.
makes sense. No, I get you. Like it's a reasonable thing to wonder about. So,
Okay. And also,
Mhm,
as far as knowing like specific like derivatives and stuff
mhm.
for the exam, I know you said yesterday that there's no like a formula sheet or anything.
Right.
So
You should memorize the ones that I wrote on the study guide.
okay, I don't
I
know.
mentioned there which ones you should remember by heart, like which ones you should actually memorize. All
Oh,
the
I see.
others you should be able to find from the product rule, quotient rule, chain rule, whatever. Yeah,
Okay. So like okay, I see. And then as far as the so like I was looking ahead in the homework a little bit,
yeah. Hmm.
uh where we talked about, or I mean I was just looking ahead. It was the substitution for the trig derivatives, like the tan of x is 1 over square root of x.
Oh, right.
Uh that is not going to be on the exam, or will it also be on there?
No, like, I guess, I don't, no, not in anything like that. Yeah.
Because like because I saw I think it was homework 3.9 or 3.10, uh
Hmm.
where it was telling you like you had to use the substitution and rewrite the derivative in terms of u instead of x, where it tells
Oh,
you.
no. Yeah. No,
Oh, okay.
nothing of that sort. Yeah.
Okay, perfect. Thank you, Professor.
Oh, yeah, sure.
All right,
Have
have
a
a
good
good
one.
one.